All right, continuing with functions, we had a setup function and a sum function. We said that unless we have a setup function to begin with, a processing program can start. Once you have a setup function, then you can have everything else. Here, in this example, when we have our setup function calling the sum function, the setup function here is the calling function, and sum is a function that is called by the calling function. Sum calculates the sum of a and b, and it will return the result back to the calling function, which is set up in this case. Sum itself is a function, so it could call another function. We'll look at an example as such. So any function can call other function or be called by other functions. So in here, there are a couple of things that I wanted to tell you about. First of all, you notice that in our function, we have int a and int b. So we need to have the type of each variable, each parameter defined. So here, if I wrote this as int sum int a comma b, that is wrong. You need to have a type for each parameter. That's the syntax. So you need an int here and an int there. We talked about how this is called the body of the function. So this is body of function, or the function block. This here, the top, this is called the function header. And the function header is really important because it's giving us, first of all, the name of the function, which is very important. The name is what it's going to be called all the time. Second of all, it's telling us the return type. So if you don't know what the return type is, so you must specify the return type. If you don't know what it is, then problems arises. And thirdly, it's telling us the type and the number of parameters. So function header is, there's a lot of information. Basically, the contract of the function is in the function header where you can see everything there. Second of all, if you have int sum, so the return type is int. This, as we said, is the return type. If the return type is int, you must have a return statement returning an integer. So if you're returning a double and the return type is actually an int, that's going to give you an error as well. So the return type must match the variable that you're returning. Let me just clean up here a little bit. I wanted to rewrite this function, so make sure, hopefully you took notes. If not, rewind and take notes of everything I've written. I just want to make a point here. So I had int sum int a int b, and here I had return result. I could write this function differently so I don't have to have the result here. So instead of all of this, I could, so let me just comment. So if I comment all of this out, so for a second, let me just take this out. Instead of writing all of this, what I could write, I could simply just say return. Let me write my. Instead of all of this, I could simply just say return a plus b, and that works just as well. So now instead of writing 3 lines, I'm just writing 1 line saying return the result of a and b, and that works just as same. The last thing I wanted to say about this particular example is the fact that here I have A and B. These could be named anything. So I mean, I could name these X and Y, and it wouldn't matter, and it would exactly be the same thing. So let's change this example up a little bit and do it this way. So if I have here only, so I can change the name of A and B here to X and Y, and just say return X plus Y. So if I wanted to draw the memory diagram for this, and this is just to make sure we are on the same page, if I have setup, in my setup I'm going to have X 5, Y as 10, and res as garbage for the time being. Then we call function sum, so sum appears. When sum appears, we're going to have X and Y. Now, this X and Y for sum are different from X and Y in setup, right? They're completely different. They happen to be named the same thing, but it's just like two different people who are named the same thing. So my name is Mohammed, another person name could be Mohammed as well, but we're different people. So this is the same thing. If I get a raise, the other Mohammed doesn't get anything, right? And if he gets a raise, I don't get anything. So we're completely different people. Same as here. So for example, if in sum, if I say X if I say X plus plus, the X in sum is not going to change at all, but the X in the X in setup is not going to change at all, but the X in sum will change. You see, so they're completely different. It's just that they happen to be named the same thing. So we do the same thing. The first X is going to be mapped to the first parameter is going to be mapped to the same. So X is going to be mapped to X is going to be 5, and then the second one here, this is going to be 10, and then we're just going to calculate the two. So we say return X plus Y, which happens to be 15, and then we return res is waiting here to catch the result of this function. So the result of inside of res, we're going to put 15, and when we say return, sum dies, it goes out of memory. One last thing, I think I said the last thing was the last thing I'll say about this example, but I'll need to say one last thing. It's a naming convention. When you're calling the function, you will call, these are called arguments. So when you're sending variables to a function, they're actually called arguments. When you're receiving them, they're called parameters. So sending arguments, receiving, you refer to them as parameters. It's just a naming convention. A lot of people get it wrong. Even in the books, sometimes you see that it's being referred to incorrectly. But the correct convention is that when you send variables, you refer to them as arguments. When you receive them, you refer to them as parameters. Okay. So I wanted to show you a couple of things with the slides. So let's look at this one. So we have a function called cube volume. It's receiving one value, so one parameter, and double volume. So volume is calculated by timesing side length times side length times side length. And then we return volume back to the calling function. Going back here, so in this slide, every single line has been labeled. So the return type is double. Notice that we are also returning a double down here. the name of the function, the type of the parameter variable, name of the parameter variable, and the function body. So refer to slide 14 if you want to see the every part of a function. So here we have function volume, and also another thing is that you need to have comments before each function. So you need to explain what your function does using comments. We'll post a commenting guideline for you to follow for these functions. So here in setup, we can use cube volume to make our calculations. So for example, I say double result 1 and I pass 2 to cube volume. And then I define a variable x as 10, and I call cube volume again, passing x to it. Now here I can just say, the output, so I'll output result 1, and I'll output result 2. So setup is the calling function. And you can see we are calling cube volume twice, and this is called reusing code. So when I said when we do functions, we're going to be able to reuse our code. So we don't need to write our code again. We can just call. So every time we need to calculate cube, we're just going to call cube volume. And here we're calling it a couple of times. So to demonstrate exactly how this works, although I think you guys already know how this works, but let's just quickly draw the memory diagram here. So if I have void setup is here, then I call cube volume. So cube volume, when I calculate it, so I am sending 2. So let's just go to the previous slide. So it has cube volume. You guys remember here was for arguments and here was for local variables. So what actually happens is, so I have side length or side len, and I was passing 2 if you recall. And then I'll go here, so the control is with the cube volume. I'll have volume. And volume is going to be calculated as side length times side length times side length, which is 8. And then we return volume. So when we say return, this thing is destroyed now, and we go back to our function here. So in setup, we had result 1, which was garbage. And when we do this, then the value of this changes to 8. Then we get another variable created, x, and that's 10. And then we get another variable created, and that's result 2. And that's garbage for the time being. And then we call cube volume again. When we call cube volume again, this thing doesn't exist, right? So a new one gets created. So this doesn't exist anymore. It goes away. A new one is created. And when that one's created, oh. Again, cube volume. So let's go back. So the control is gonna be with that one now. So we're going to have side length, we sent x to it, which is 10, and we're going to have volume. Volume is going to be calculated as 10 times 10 times 10, so that's 1,000. When that's 1,000, then we say return volume. So this is destroyed, and we go back here, and result 2 is going to be overwritten as 1,000. So when we finally get our, when we get to this part, this is going to print result 1, which we calculated to 8, and then this is going to calculate result 2, which we calculated to 1,000. So a function gets called, does its thing, it gets destroyed in memory, goes away, then we call it again, then it reappears in memory. So that's very, very important. Every time you call a function, that function will take over control, take over the control of the program, does its thing, and then it just gets destroyed. So all functions, when they do their task, they're destroyed, including setup. The only one that keeps on repeating and repeating and repeating is draw, which is being repeated by the processing process, which is transparent to the programmer. So hopefully that is very clear for everybody. So let's do a really quick example again. So we are assuming there's some code here. So if you have y, we're assuming that y has been declared. So y needs to be a double. Why does y need to be a double? Because it's being sent to function square. Function square is demanding that the input is a double. So here we have y, it's probably, so it's not an int, it's a double. So we're going to have double y, let's say 10. Here we're going to say double y squared equals, and we calculate the square function. When we calculate the square, when we call the square function is called, it does its thing, and value 100 will be returned and stored in y squared. So hopefully that is also clear for everybody. One thing that I wanted to mention again is that comments need to be placed before functions. Comments are of course for yourselves and for your colleagues, TAs, instructors, whoever is going to be reading your code after you. Comments need to state comments need to include the purpose of the function. They need to explain the meaning of parameters. They need to state what is the returned value, so what is the output, and also state any special requirements that the function may have. Don't worry about the last one so much, but the above we have learned about, and you guys should include in your comments. All right, I'll be back with more. Thanks.